Hello, this is from Mr. Bose to year 4 and to year 3. Hello, year 3. So we are all going to do maths together today, which I'm very excited about. Some things will be different for year 3, so I'll explain as we go through. The first bit you're going to be able to just ignore because year 4 are going to mark their work from yesterday, or this in case it was Friday's work. So they're going to mark their work now. You can ignore this. Year 4, pause the video and tick cross, work out what you got right and wrong from last week. Okay, everybody's back. So could you write down the date and the learning objective, please, for today's work? Find a new page in your book, write down the date and learning objective. Tenths as decimals on a place value grid. So we're going to understand, we're going to learn about tenths as decimals on a place value grid. Pause the video to write that down now. Okay, before we jump into too much more, I wanted to look at place value. So I've got 4 representations on the screen here of place value. You might remember from the number blocks, we've got on this side, we've got our ones, we've got tens. When you stack 10 ones together, we've got tens. We've got 100 square here, and we've got 1,000 cubes. So you might remember those from the number blocks. Today we're going to be looking at tenths. So actually, we will be drawing an extra little bit on a place value chart. Instead of stopping with the ones, we would actually have an extra bit on the side, which would be our tenths. Okay, and they would be represented over here. So in between the ones and the tenths over here, let's write tenths like that as a fraction. You will have a little, what's this? That's right, it's a decimal point, not a full stop, it's a decimal point. So, for example, on this representation, this is also a place value chart here. We've got ones and tenths on this one. So, same as we've got ones and tenths over here, we've got ones and tenths on this side here. And we know that this, as a number, would be 3, because there's 3 discs in the ones column. 3 red discs, and we've got 6 purple discs, so it's going to be 6 tenths. And again, there's that dot, which is our decimal point. Sometimes you get ones and tenths without any discs in, and you write in your own numbers. So we could have 3.6. Here's another place value chart here, exactly the same thing. This one has hundreds and tens and ones, so it just goes a little bit further than this one over here, but it's doing the same thing. And you can see you've got here written in this extra bit, tenths, which is 0.1 or 1 over 10 as a fraction. So again, if I was writing 3 whole ones, 3 ones, and 6 tenths, I would write simply 3 and 6. Let's put this in here as well. We could have 3. If I get my yellow pen, let's get a darkish yellow. So we could have 3 little squares, 3 little ones, and we could have our tenths as well. I don't know how we'd write those, so we just have to write the number 6. We don't really put those into pictures. So 3.6. So that's place value charts and how we represent numbers on place value charts and see what the different numbers look like. And over here, we have something else which even probably year 4 haven't come across very much. These are called a whole part model or a part whole model. So on each of these 3 little pictures, you've got the whole. And the whole one is here. And these are the 2 parts. So the 2 parts go together to make the whole. So very simply, I can put a 2 in there and a 7 in there. And what would the whole be? It's going to be 9. How do we do it? Stick 7 in your head, count on 2 more, 7, 8, 9. Okay, let's do a different one over here. we could have the parts are going to be 3 and 12, and the whole would be, you've got it, 15. Sometimes you don't get the two parts. Sometimes you're given one of the parts and the whole. So they're telling us that the whole here is going to be 11. And this part is 8. And then the puzzle is, what is the other part? So if we've got a whole and a part, the whole is 11, one part is 8. How much more than 8 will I need? What will I need to add to 8 to make 11? So 8, let's have a look. 8, 9, 10, 11. I'm going to say I'm going to add on these to get my whole 8, 9, 10, 11, 3 more. So that's a part-whole model where you've got the parts. This is a part, this is a part, and then you've got the whole. What does it total up? So we're going to be looking at those a little bit today as well. Okay. Another thing before we get started, Year 4s know about this, but I will put a link on the web page, on the school website, to this little website. Okay, it looks like that. In the top left-hand corner here, it says MathSpot. So it's a funny name, but it's very useful. So it's called MathSbot, B-O-T, which I think is a little bit of an abbreviation for robot. MathSbot, and you are looking at something called manipulatives. If you go to MathSpot, click on the link for manipulatives, you can see there's all sorts of things there when you scroll down, and one of them is to do with place value. So here you can see at the top of the screen in purple box it says place value counters, and you can choose your counters. So I've started with the tenths just here. There's my tenths, and I'm just going to go up to the tens. Some people go up to hundreds or thousands. Look, I can drag out thousands and different hundreds and things if I want to make up numbers. So I want to make up 1,200 and 1,230, 40, 50, 1,251. I can drag these out. I can also tidy that up. Today we're looking at decimals, so I would start here with the tenths, and I'd go up to just the tens today. Useful things we can do is we can drag them out, obviously, to see what they look like when we're trying to build numbers, but we can also exchange, because one whole one that I've just dragged out in yellow here has a number of tenths inside it. How many tenths make a whole one? Well, if this was on a number line, and our number line was starting at 0, and it was going all the way up to 1. Not very far, is it? It's just going 1. We're going to jump 10 counts. Each tenth would be 10 counts, so we need 10 of them to get up to 1. So we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each one of these jumps is 1/10, and all the way they get up to 1. So on the MathSpot, if you say, I've got this one here, and I'm just going to use that the word above there where it says exchange, you can exchange that whole one for tenths. And look at them. This is what tenths look like. And if we check how many they've given us, it should be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Useful way of looking at different numbers. Okay, let's get on to today's learning. I'm going to go through some examples of the questions you're going to have and show you how to answer them. Then you're going to be given some work to do. You will have 2 types of work. It's called the spicy work, which is to start. Then we have the spicier work. If you're happy with both of those things and think you're doing really well, you can look at some more examples that I'm going to show you and go on to the spiciest. So that's how it works with Year 4 and now with Year 4 and 3 together. Start off with the spicy, then do some spicier questions, and finally the spiciest. Okay, first thing, just to get us warmed up, circle the images that show 4/10. Circle the images that show 4/10. So we've got a 4, which is the numerator on top. We've got a 10, which is the denominator underneath. And which ones show 4 out of 10? So the denominator shows everything. So let's count. Have we got 10 in our first example here? Have we got 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We do. We have 10 there. 10 little squares in there. And it's saying circle all the images that show 4 of 10. So it's got 10 altogether in here, but are 4 of them coloured in? 1, 2, 3, 4. True. So I'm going to say, yeah, that's true. That shows 4/10 because there are 10 squares altogether and 4 are coloured in. Let's try this one. Are there 10 altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, there's 10 altogether. Are 4 coloured in? 1, 2, 3, 4. Yeah, I think that's true. Let's try this one. Are there 10 altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are. So that's correct. But are there 4 of them, 4 of the 10ths coloured in? I've got 1, 2, 3, 4, 5, 6. No. This shape here, I'm not going to circle it because I think it is showing 6/10. And so on. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares, and 6 have got dots in, so that is going to be 6/10. It's not going to be circled because I'm looking for 4/10. 1. Ooh, let's do this off the top so we can see it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got tenths. Are 4 of them coloured in? 1, 2, 3, 4, 5, 6. No, that's 6/10 as well. That doesn't work. I can see this one. 1, 2, 3, 4, 5, 6, 7. Yeah, there's 7 coloured in there, so that's not going to be 4/10. So I'm looking at these two at the top as being the ones that are 4/10. Let's see what the answers are. Oh, hey, we've got 4/10 and 4/10. Ah, that's interesting. We've got this one circled here as well as being 4/10. So we could say that 4/10 are white. But these two are definitely showing 4/10. So 4/10 are white and 6/10 are blue. If that's the case, then I would potentially even circle this one here, because I've got 10 altogether. Check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I look at the white ones, 1, 2, 3, 4 of them are white. So I would actually agree with that one as well. Okay. Complete the table with the missing fractions or decimals. So on this table, you've got a row at the top and you've got a row underneath. These are the tenths as fractions on the top line and tenths as decimals on the bottom line. So 0.2 is 2/10. And we looked at that earlier in the place value chart. We'll have a look at that again. Here in our place value charts, we've got 3.6, but if it was 0.2, that is the same as 2/10. And as you go along a number line, you go 0.1, 0.2, and so on. So 0.2 is 2/10 in here. 3/10 would look like 0.3. 0.4 is, do you know it? Yeah, 4/10. And then 0.5 would be 5/10. So sometimes you'll have a question where there are missing numbers and you've got to work out the pattern, not just put in any number you like. In this case, what's underneath 0.4 has to relate to, will be the same as what's on top here, which is 4/10. There we go. There's the answers for us. Match the fractions to the correct decimal. Matching task. So all the boxes on this side need to match to the boxes on this side, on the right. So let's have a look at what's going to match to where. 8/10, 6/10, and 3/10. 8, 6, and 3. So quite straightforward. We can see that 0.8 is 8/10. Oh, why does it do that? Excuse me, children. I'll just get that back if I can. Sometimes when I draw a line across the screen, it thinks I'm trying to move the browser. Are you going to come up, please? And we're back. So 8/10 is 0.8. Whoops, excuse me, get my pen. 6/10 is, or 6/10 is 0.6 as a decimal, so those two match up. And 3/10 is 0.3, so those two match up. Thinking about the decimals on this side and how they match up with the words and the fractions on this side, they meaning the same thing. Oh, there we go. All good. Use the image to complete the fraction and the decimal. Use the image. So image means the picture. So they're talking about this thing here. You've got to use this picture to complete the fraction and the decimal. Okay, so we seem to have the answer straight away here. 0.4 is the decimal because there are 4/10. 0.1, 0.1, 0.1, 0.1. I remember we looked at tenths when we were using this. So we can look at 4/10 like that. Altogether, that's going to be 0.4 or 4/10. Okay. And we can always put those into a number frame if we want to. There are 10 spaces in the frame altogether, and 4 of them have got tenths in them, so it's 4/10. Come back to our lesson. 0.4 is 4/10, and that would be written as a fraction as 4/10. 10 altogether, 4 of them have got tenths in. True or false? That's an interesting question. Read the question carefully. True or false? The arrow shows 0.7. So I've got 0 at this end of the number line, and I've got some decimal numbers here, and it goes up to 1. So it's a very short number line. It goes from 0 to 1. It doesn't go up to 2, 3, 4, 17, 24, 500, just from 0 to 1. And it says, does it show 0.7? And the answer would be true, because between 0.6 and 0.8, you would get 0.7. And you can write those things in if you want to. So here would be 0.1, 0.2, 0.3. Get the pattern? All the way up to 1. Ah, here we go. Here's one of our part-whole models. Oh, I've got the sunshine coming across. You see me in the sun now. It's nice sunshine coming in through the window at the moment. I'll try not to get too bright though. So our part-whole model, we've got a 9/10, and that's the whole. Can you see that you've got 2 arrows going into that one? So 0.9 is our whole, and these are our 2 parts. So what 2 parts are going to make 0.9? I've got 0.2, which is the same as 2/10. 0.9 is the same as 9/10. What other decimal, something point something, is going to make 0.9? So if I've got 2/10, or 0.2 to get to 0.9, I need to think, what am I going to add on? 2 and something makes 9. It's going to be 7. But where am I going to put the 7? Is it going to go there? Or is it going to go there? What do you think? That's it. 0.7. So get it right. 7 goes on this side, and you need to keep the placeholder so we know that it's a decimal. Okay, I'm going to pause this and move myself out of the bright sunshine, otherwise I won't be able to see my screen. Okay, let's check that answer. There you go, 0.7. It's the part-whole model, yeah? We'll be looking at these again at different times. This is the whole, and these are the two parts. I've got one part there, and they go up the lines, as you can see, to make the part-whole model. Circle the decimal number shown on the place value grid, the decimal number on the place value grid. You've got three answers here. You need to choose which one is going to be correct. You've got to circle it. We looked at these place value grids. In the ones column, I can count the yellow dots. We've got 1, 2, 3, 4. And in the tenths column, I've got 1, 2, 3, 4, 5. So it's going to be 4 and a 5. Place value, remember, always has a decimal point in between the ones and the tenths, so that's 4.5. There we go. Should be 4.5. There you go. Add counters to make the place value grid correct. So here, they've given you the answer. You've got to add counters. Always important that you read the question and then you read it again. So let me get some counters. We can get some yellow ones. 3.6. So I've got 2. I need to add one more. There's 3. And I need some green ones. 0.6. 1, 2, 3 more. Altogether now I've got 6. 1, 2, 3, 4, 5, 6. 1.4. I can see that I've got 4 tenths here. The green one is the tenths. So that's 3. There's 4. And 1.4. Let's get my gold, was it? Yeah. 1.4. There you go. Oh, they've added red ones. I quite like mine. I've got the right colours. Doesn't matter what colour you're doing if you're doing this sort of thing at home, as long as you get the counters in there. They call them counters or dots or spots, whatever you want to call them. Get them in there. Complete the sentences below. So we're reading the sentences. Now, important that we read this out carefully. It's 3.1. 3.1, remember that's 3 whole ones, 3 ones, and 1/10. So that is the same as saying 3 whole ones and 1/10. 3.1 is equal to how many ones and something tenth? So we know it's 3 ones and 1/10. 4.9 is equal to ones. How many ones? It's got 4 ones. And how many tenths? It's got 9 tenths. Okay. There we go. Just going to grab a darker pen. The place, true or false? So again, looking carefully at the question, true or false? The place value grid below shows 5 ones and 4 tenths. 5 ones and 4 tenths, true or false? Let me count the ones. I've got 1, 2, 3, 4. I've got 4 here and they're telling me 5 ones. So I'm going to say straight away that this is false. And they're also saying there's 4 tenths. If I count the tenths, I've got 1, 2, 3, 4, 5. So they've actually switched it round. It should be saying 5 tenths and 4 ones, I think. Let's have a look. False. There are 4 ones and 5 tenths. Yeah, there's 4 here and 5 there, and as a decimal that would be written as 4 point decimal point 5. 5 tenths is the same as a half as well. Okay, time for you to do your work. There's 2 levels of work. I will show you the first set. I think there's 2 sets of questions. This is called the spicy work for you to get on with. You need to put the question number in your book, in the margin, before you try each one. Write them out and join them up. So note you're starting with 5A, then you've got 5B, 6A, 6B. It's important that you write those question numbers down, because if you write question number 1, when we come to mark them in tomorrow's lesson on Tuesday, you won't know which one you're marking. So if you put 5A, and you'll be able to mark it tomorrow, you'll be able to match it up to the answer for 5A. If you don't want to draw these out in your book, what you could simply do is copy them down. So for example, if I thought 4/10 is going to be matched to the correct decimal and it's going to be matched to 0.9, I would just write this in my book: 4/10 equals 0.9. But I don't think you're going to be writing that because you know which fraction is which on the decimal side here, and it's not going to be 0.9 for 4/10, is it? Okay, so that's the spicy work. Pause the video and have a go at that now. Continuing with the spicy work, pause the video now. Note you've got questions 7A, 7B, 8A and 8B. Use those question numbers. Oop, look, here's our part-whole model, 2 parts and the whole. Spicier work. If you want an extra challenge, which most of you will, go for this. Matching again, you've got a matching task and you've got the image. Remember, it says use the image to complete the fraction and the decimal. So this is the image, and here you've got a fraction to complete and a decimal to complete. So remember how we use images? We count how many there are all together. Did you get that? However many there are all together, that goes down here. And then how many have got circles in? That number goes up here. So there's your fraction, and then you convert that into a decimal. Do the same for 10b. Finishing off the spicier work, 11a, 11b, 12a, 12b. True or false, true or false. Part-whole models again. Just don't be too worried about these, because there is more than one answer. I could think of different ways that I could think of some parts here, some decimal tenths to write in here that would add up to my whole. This is my whole. So there's more than one answer for this. Have a go. Pause the video now. Well done, year 3, year 4. Now, if you want an extra challenge, get onto the spiciest work. Let me show you some examples. So we have to read the problem. Daisy is using straws to represent tenths. 1 straw is equal to 1/10. Let's read that again. Daisy is using straws to represent tenths. 1 straw is equal to 1/10. So this is a straw, and Daisy says that is 1/10. They're all tenths. And she says, I have made 0.7. So a question is asking, is Daisy correct? And explain your answer. So I have made 0.7. Is she correct? And explain the answer. Well, if she's made 0.7, I know that that is the same as 7/10. And this straw here is 1/10. So let's see how many tenths she's got altogether. Mark them as I count them. Pause the video and count them if you didn't get it. Yep, I got 9/10. So I'm going to say she's wrong. She is incorrect, because I think she's got 9/10. Let's have a look. No, Daisy is not correct. No, because she has used 9 straws, which represents 0.9. Exactly. Because when we counted, we saw there were 9/10, and that's why we wrote that down. 0.99 Look at another one. Which is the odd one out? So there are 4 representations. There's A, B, C, and finally D. Which one is the odd one out? So we have to read them carefully. This one, A, 7/10. It's a fraction. 7/10 is 7/10. B says 7/10. C says 0.7. And finally, D has a place value chart, and it's got no ones, there's nothing in there, and it's got some tenths. Let's count the tenths. There are 1, 2, 3, 4, 5, 6 tenths here. So in between the ones and the tenths, there's a decimal point. So actually this would be, D would be 0.6. So looking at those, I think A, B, and C are all the same. They're just shown in different ways. And D is the odd one out. So that's how you convince somebody, by saying we need one more tenth in here. If we put another disc in, we'd be all right. See what it is. D is the odd one out because it represents 0.6 and the others represent 0.7. So explaining your answers, yeah, using a sentence. Okay, order these numbers from smallest to biggest. Order the numbers from smallest to biggest. Now, this should be straightforward. The thing that's making it difficult is that some of them are written in words and some of them are written in fractions. What we need to do to help you complete this is to convert them. So what you could do is you could think, well, 7/10, I know that that is going to be 7/10. 5/10, I know that that is going to be, as a fraction, 5/10. That's one way of doing it. Now I can compare 7/10, 3/10, 5/10, 9/10. It's quite straightforward to see that they're all tenths. So we're going to start with 3 as the smallest number here. 3, and I've got a 7 and a 5 and a 9. 5 comes next. So 3/10, 5/10, 7/10, and finally it's going to be 9/10. I hope. Yay! Oh, but look, they've written it in their way they've done with the words. So when you converted it and you found out that this 7/10 is actually going to be the third one along, what you need to do, obviously, is write it in words, smallest to largest. Well done. Laura spilt paint on her place value grid. She says, now this is what Laura's saying, okay? I had 6 counters, and the tenths column had an even number of counters in it. Which decimal numbers could Laura have made? So we've got the tenths column, and she had 6 counters altogether, so she's got 6. They are on the place value grid, but we don't know exactly where they were because she spilled paint on it. She says in the tenths column, so in this one here, had an even number of counters. What numbers could it have been? So even numbers, let's think our odds and evens. Even numbers are 2, 4, 6, 8, and 10. So these are our even numbers. Put commas in between. 2, 4, 6, 8, 10. So if we have an even number of tenths, we could have, we've only got up to 6, so actually we can't use 8 and 10. So we could have 0.6, or we could have, I was going to say 1.5. If they put 1 counter over here and 5 over there, but that's not going to work because you have to have an even number. An even number, not an odd number, an even number of counters in there. So what we're going to have to do is scrub that and maybe move another counter across to here. So if I move another counter across to there and I grab my rubber, yeah, so I've moved one across. So I get my rubber. That's the one that I moved across. Let's just get rid of that. So I could say 2.4. 2.4. Actually, I could take 2 more from the tenths column. If I scrubbed out those 2, that one and that one, and I put those 2 over here, those could be 1, so it could become 4.2. So there's a few different answers: 0.6, 2.4, 4.2, because each time I'm using my 1, 2, 3, 4, 5. I've got to have 6 counters, but it's got to be even in this column. See what they've got. There you go, 0.6, 2.4, 4.2, or you could have 6.0. Ooh, odd one out time, guys. Odd one out. Which is the odd one out? Again, we've got 4 representations. We've got A, we've got B, we've got D, and we've got C. These are mixed numbers where you've got whole and part numbers. So 7, A says 7 and 2/10. B says 2.7. C says 2 wholes and 7/10. And D is shown on a place value grid, and you've got the ones. In the ones column here, you've got 2 of them. So we could say that's 2 ones. And the tenths column, we count them: 1, 2, 3, 4, 5, 6, 7 of them. 2.7. This one here, let's look at A. 2/10, remember, on a place value is 0.2. So this number, let's get a different color. 2/10 on a place value is 0.2. But we can't forget there's also a 7 there. So if we put the 7 up, we end up with not 0.2, because the 7s are whole ones. I need to grab my rubber, rub out this 0, and say that it's actually 7 whole ones and 2/10, 7.2. Ah, now we're getting a pattern. Look, I've got 7.2 up here, I've got 2.7, 2.7, and the last one, C, over here says 2 wholes and 7/10. 2 whole ones and 7/10. So I'm going to say that, yeah, which is the odd one out and why? You see it? That's it. A is the odd one out because all of the others are the same value, which is 2.7 or 2 and 7/10. How do they explain it? Yep, 7.2 and 2.7. A is the odd one out because it shows 7.2 and all the other representations show 2.7. That's the sort of thing you're going to have to do. You're going to write a sentence to explain your answers. If it says, explain your answer, no problem. Okay, Liam is using the place value grid to make decimal numbers. He says, I have 3.5 using 8 counters. Is Liam correct? 3.5 using 8 counters. Let's see how many counters he's used. 1, 2, 3, 4, 5, 6, 7, 8. He's used 8 counters, so this is correct. Has he made 3.5? Ah, no. I think not, because he's saying I've got 3 whole ones. Over here, he's got 5 whole ones. So let's look at this. Liam's incorrect because he has used 5 counters as the ones column. He's used 5 counters in the ones column and 3 in the tenths column. He's made 5.3. Remember, when you're trying to work these things out, you can obviously go back to the math spot if you want to. Let me just tidy that up. You can get a frame out like this one. If you don't want a number frame, if I click on here, I could have, ooh, what's this? Table in words. Oh, look, tens, units, and tenths. That's quite handy. Look at that. All the thing I'd like to see is I'd like to see some decimal points down here, but we know there's your 0.1s, and you can stick your ones in there. So you can actually make up the numbers with different things. If I've just dragged a tenth into there as well, I think I can copy another. Yeah, drag them in as well. So making numbers here to help you solve the puzzles. So for example, I've made 1.4 there. Using those could really help you solve this sort of thing. Right, I think that's nearly, yep, Time for the spiciest work then. This is the hardest work. Give it a go. Give it your best shot. Remember to write the answers in your books under the question number. So we've got question 5A, 5B, 6A and 6B. That will make sense when you're marking the work tomorrow. Sometimes you have to add counters in. Sometimes you have to find the right answer. And it goes on to 7A, 7B, 8A and 8B. Quite a long lesson today. Well done for sticking with it. And I will see you again tomorrow. Bye-bye to Year 3 and Year 4.